Hello everybody and welcome to video lectures of operations research. And in this lecture we will look at the data envelopment analysis and actually so-called dual approach. So what's the idea here? So in the last video lecture we learned that DEA, data envelopment analysis, so we want to calculate the efficiencies of our decision-making units. So the efficiencies come from this kind of LP. And what's the story in this lecture? In this lecture we consider the dual approach, which is of course related to the dual LP. So this is an LP. It means that it has a dual. So we find out the dual and then let's see if we can understand the dual approach to data envelopment analysis and get more insight on what is going on there. This is precisely the topic of this lecture. So let's go here. And it turns out that in the dual approach, so in the primal approach, the decision variables were the weights associated with inputs and outputs, and the constraints were given by the DMUs. Each DMU gave a constraint that the efficiency calculated for that DMU cannot exceed 100%. So now we know that in the dual approach, the constraints become the variables and vice versa. So somehow in this dual approach, we have decision variables that are in this business typically called lambdas. So we have n decision variables and they are all connected to somehow with these DMUs. And in a way, the solution can be somehow, this is very vague talking at this point, but I hope it becomes more clear later. So we have a decision, we can think about the DMU k has weight lambda k, and then if we sum them all up, then this could be interpreted as so-called a virtual DMU. And this virtual DMU somehow has the same business mix as the DMU O under observation. So these lambda k's are now calculated for the DMU O. And then this virtual DMU is 100% efficient, while the original one necessarily is not, maybe or maybe not. So that was some kind of vague idea how the dual approach could look like. But without further ado, I will just give you the dual formulation. So to find out how this dual formulation was, so this is the dual data envelopment analysis LP formulation. To understand how this is constructed from this in detail, if you really want to see the derivation in detail, then go to these notes here and there chapter 6. It's explained here. Here I will simply interpret the dual a little bit and but skip the actual mathematical or symbolic derivation, if you like. So the dual DEA is the following. So the primal was a maximization, so the dual is a minimization. So we minimize theta. So this funny looking letter is also a Greek theta. And what are the constraints? So we have constraints for each outputs weighed by the decision variables. Lambda should be at least as the outputs of the DMU we are considering. And for the inputs, it goes the other way around, except that here there is this theta. And lambda theta, I'm sorry, this theta should be written like this kind of theta. So that's the dual DEA. Let's try to understand this a little bit. So we want to minimize theta, so there is no objective function here. So theta is only given here. So if I look at the lambdas, so this is y times lambda, this produces a virtual DMU where I take lambda k of each outputs. So the virtual DMU is this, its output is y lambda. So the idea is that I recombine lambda times each of the DMUs and look what happens there, and I look at the outputs. So this virtual DMU, y lambda, should have the outputs as big as the outputs of the DMU I'm looking, or better. Alright? And the inputs go the other way around. So again, this is the virtual DMU, inputs x times lambda. They should be less than equal to the inputs that I have if I scale my inputs with theta. So if this theta happens to be 1, then I have a virtual DMU that has at least the outputs are better or as good as the DMU under considerations, and the inputs are worse or as equal to what I have now. Then this would mean that the DMU under consideration, DMU O, is 100% efficient. And if I need to scale the inputs here, then the efficiencies become worse and worse. So that was the short kind of intuitive explanation what the dual approach to the DEA is. And finally, let's have a couple of exercises here. So this exercise 11.7, so you should solve the Imperial University's problem 11 by 11.1 that we solved in the previous video lecture by using dual LP formulation 11.6. So this requires, of course, to write this in a standard form and solving the LP, but this shouldn't be too difficult. I mean, this is more closely related to a standard form LP than I think that the primal formulation, which is here. So the dual formulation is maybe a bit more difficult to understand what's going on there, because you have to understand this thinking about virtual DMU, but then as a form it's probably easier to transform this into standard form and solve by GLPK. So in some sense the dual formulation is easier, in some ways it's more difficult. And finally we have an exercise, and this is a theoretical, where you have to, I actually ask you to derive the dual DEA LP 11.6, so this one from the primal that you can see there. And yes, well, this is very easy if you cheat and look at my old notes, but well, maybe I don't give this as an exercise for you because it's just copy paste from my old notes, the derivation, it's given there. That was all about data envelopment analysis. See you in next video lectures. Bye.